Yes, hello Surya, welcome on YourPedia platform and let's start your heat transfer snap for your final DRDO interview. Okay. So Surya,
Mm.
what do you know about heat transfer? What you studied in this particular subject?
Sir, heat transfer means it's a transfer of heat from hot body to cold body, sir. Yeah, or cold body to hot body with the presence of some external air.
So heat transfer takes place from cold body to hot body or hot body to cold body?
Hot body to cold body, sir.
Why you mentioned cold to hot?
Because in refrigerator and air conditioner, that things happen, sir.
Are you sure in a refrigerator heat transfer takes place from cold to hot?
Actually, it extracts energy from the cold reservoir and by utilizing the work and it transfers
Fine,
to
fine, fine. That is the kind of effect we are getting. But heat is getting transferred from hot body to cold body or from cold to hot body, even in refrigerator.
um, sir, hot to cold, sir.
Okay.
Because
So
the temperature of the refrigerant will get more than the ambient and then
actually,
it
when
will
a refrigerant flows in a particular, tubes of a evaporator, so by which mode of heat transfer the heat transfer takes place?
uh, it is by through convection, sir.
Convection.
Yes, sir, convection heat transfer
Convection with phase change or without phase change?
with phase change, sir, boiling.
So kind of boiling is going to happen.
Yes, sir. Yes, sir.
Hmm. You heard about pool boiling, Surya?
Yes, sir.
Can you explain something about that?
Sir, pool boiling means it is not there are two types of boiling, sir, broadly divided into two types, sir, pool boiling and flow boiling. In pool boiling, the water will not flow, sir. It will be like in a stagnant static in a bowl or bowl kind of thing, and we heat it like there are different types different stages in pool boiling, sir, like
Mhm.
natural convection boiling, nuclear boiling, and transition boiling and film boiling, sir. Four types of boiling, sir, in pool boiling.
Achha, tell me something about film boiling.
Sir, in film boiling, the temperature difference is more than 120 degrees centigrade, sir.
Mhm.
They in film boiling, there is a vapor. There is a formation of vapor film on the base of the bowl, and the heat transfer mainly takes place through direct radiations, sir, from the bowl to the water.
Surya, in which particular state we are, stage actually we are going to get the more or maximum heat flux?
Maximum heat flux is in nuclear boiling, sir.
Nuclear cooling. Why? What is the reason behind that?
Sir, because after the nuclear boiling, there comes the phase transition boiling, sir, where the vapor chunks start forming on the base of the vessel, sir. It actually prevents the convection, sir. And but in contrary, when the whole base filled with any vapor layer, the by the time the temperature difference between the base and the liquid is more than 200 degrees like that, sir, so it will directly radiate. But in the nuclear boiling, with the help of nucleation sites, more boiling will takes place, sir.
Mhm. Okay. So, Surya, what is convection heat transfer coefficient and on what factor actually it depends?
Sir, convection heat transfer coefficient, uh, it actually it gives us it is a measure of uh, it is the it shows us how better the heat can transfer from the body to the medium, sir. Means if the it depends on the body shape also, sir, not only just area and the temperature difference, sir.
No, on what factor it depends? How we can enhance the convection heat transfer coefficient? For example, you are having a maybe suppose convection heat transfer is taking place, okay, maybe forced or natural convection. So for that particular mode, we want to increase its heat transfer. So how we can increase that convection heat transfer coefficient?
Sir, heat transfer coefficient can be increased in many ways, like increasing the velocity of the fluid or adding the extended surfaces like fins, or we can use some complex things like heat pipe. We can use these things, sir.
So can you tell me something about critical radius of insulation?
Sir, as the thickness of the insulation get increased, generally like for a plain wall, if the thickness of insulation get increased, the heat transfer goes on decreasing, sir. But for a say hollow cylinder, for a hollow cylinder, when insulated from outside, as the thickness goes on increasing, sir, the conductive resistance increases, sir. But at the same time, the convective resistance decreases because of the increase in the surface area, sir. So at one point of time where the convection heat transfer uh, dominates the conduction, then at that point we call it as a critical radius, sir.
So what is the significance? What is the use of that particular concept?
Sir, it helps us for insulating the electrical wires, sir. For example, we insulate electrical wires to prevent the electric shock and also to dissipate the excess heat from the wires, sir. For that reason, if we there should be optimum thickness of the insulation, sir. Because if we put more insulation, then it increases the it actually decreases the heat transfer and also increases the weight of wires, sir. But if we decrease the thickness of insulation very less, then it cannot dissipate heat effectively, sir. So for optimum thickness, there is a optimum radius called critical radius, sir. If you put that one, then the heat transfer for a particular heat transfer heat generation rate, the heat transfer will be maximum, sir.
So yeah, for example, let us consider we want to design the walls of a particular cold storage. Okay,
Yes, yes, sir.
there is a cold storage plant, and we are interested in designing the walls of that. Okay, so suppose we are having 3 layered insulation available with us.
Yes, sir.
So all layers are having same thickness, but their thermal conductivities are different. Okay,
Okay, okay, sir.
so we are having 3 different layers of material. All are having different conductivity, but their thickness are same. So now, in which particular order you will keep them?
Sir, I will put the insulation with least thermal conductivity near the wall of the that cold storage, sir. The
Why?
like, sir,
Why you will keep the lower conductivity material inside?
because because sir, our motto is to prevent heat transfer from the cold storage, sir, but not from the whole system. So if we put the least the thermal conductivity material near the walls of the cold storage, then it decreases the heat transfer through that particular through the first layer itself, sir. It
Are you
prevents
sure
the
about that, Surya?
yes, sir.
What you feel like? Will there be any change on the total thermal resistance, whether you are keeping the lower conductivity material inside, outside, or in between the 2 layers? There will be any change in the total resistance, or that total resistance will remain same?
Hmm. Total will be same, sir.
Total resistance
Total,
will remain same.
yes, sir.
Then
Because
how you can say that heat transfer will be lesser when you are keeping the lower conductivity material inside?
hmm, it actually yes, sir. I think I am wrong, sir. But it actually prevents the heat from the first level, from the cold storage to enter into second layer, sir. It sorry, sir. I don't know.
Okay.
I,
Surya, what do you understand by steady state?
steady state means, sir. While conducting experiments, after getting after a like significant amount of time, the variation in parameters remain in a particular at a particular like uh, particular value, sir. That means, for example, if say heat is passing through wall, and after a very long amount of time, the heat input uh, from the wall can be equal to like the heat output from the wall. If it is there, then like steady state means like when entropy generation is zero, sir. Change
Acha,
in entropy.
how you will check the given particular wall or maybe any particular system is in steady state? How you will check that?
Sir, if it is in steady state, then the entropy change for the particular wall would be zero, sir.
What will be zero?
Entropy change, sir, delta S.
Entropy change of what?
The wall, sir. If we take wall as the system, then by since heat input equal to heat output, then the total entropy change must be zero, sir.
So you are like, suppose if you want to check like the given motor, given fan, or maybe any particular device is in steady state or not. So you are going to check the entropy change. It's entropy change.
No, sir. In heat transfer problems, we can use that entropy change, sir. Since the fan is like it converts electrical to mechanical energy.
So there is a fan, there is a light bulb, okay,
Yes,
and
sir.
these devices, appliances are in some kind of steady state, because then only we can say whatever energy we are giving, that is, you know, converting in
Yes,
some another form. There is no such energy accumulation there inside the system.
yes, sir.
So for that, is it required to check the entropy change? Because that will not be practical actually,
Yes, sir.
because
Yes,
there
sir.
is no such device available to us with which we
Yes, sir.
can directly
Entropy.
measure the entropy change. So that
Yes, sir.
analysis will be much more theoretical.
Complex. Yes, sir.
Mhm.
Mm. Sir, at a steady state. Means, sir, if at all, if, for example, if we take fan, then if at all the speed of fan is not changing, then if for a long time, then I think we can means steady state means like it,
Mhm.
it is independent of time, sir.
What is independent of time?
Means after a particular instant, even though we run the equipment for so much for any time, then it remains in the same state, sir. For example, the temperature would not increase or not decrease like that, sir.
Okay. So you tell me something about time constant. What is time constant? What is the significance of the time constant in heat transfer?
Yes, sir. Sir, time constant is generally we use it in the measuring the temperature of thermocouple, sir, like lumped heat body. It actually tells us the uh, time required for a body to reach 63.2% of its initial temperature difference, sir.
So what is the significance of that?
Sorry, sir, I don't know.
Okay. So my last question to you. What do you understand by gray bodies, gray surface?
Sir, gray bodies, the emissive power of gray bodies, it, it those are independent of wavelength, sir. Independent of the wavelength, but they are not. Uh, they are diffuse bodies, sir, but they are dependent on wavelength.
No, I'm not getting. Please repeat once again.
The emissive power of the gray body.
Emissive power.
Yes, sir. Emissive power.
Emissive power or
Of the
emissivity?
emissivity, sir. Sorry.
What is the difference between emissive power and emissivity?
Emissivity is a property of surface, sir. The emissive power is its effect. Emissivity is a property of the surface, sir, denoted by epsilon. Emissive power is,
Emissivity of a surface. It depends on material or what? Surface condition or both?
it depends on surface, sir. I don't know whether it is depends on material or not, sir.
So for what kind of surface it is more? Like suppose you are having two surface, shiny and another one is rough. So for which emissivity will be more?
That I think it's for rough surface it will be more, sir. I am not sure about it.
For rough surface it is more.
Yes, sir.
Okay.
Because for shiny surfaces the reflectivity can be more, sir.
Fine. Good. Okay. Surya, let me. I think now I can provide you the feedback.
Yes, sir.
Surya, you started very well actually. Very accurately you answered initially all the questions. I feel when I asked you about that whole question, you faced some difficulty in answering that question, and after that, I observed some kind of lack of confidence. Okay. So initially you started very well. So in interview also it is going to happen. For example, you are unable to answer one of the question. So don't carry that kind of thing in your mind. For example, if you missed one particular question, maybe that easy or difficult, forget about that. Okay. So if some question you missed, just leave that. Move to the next question with same energy, same a kind of confidence. Are you getting? So yeah.
Yes, sir. Yes, sir.
So don't carry any earlier impression. Second, your knowledge is looking fine. You are answering fine. Like most of the question you approached in the right manner. I started with some basic, you can say convection question, because somewhere you mentioned that, because that's why I moved in that boiling area, because you mentioned like heat transfer can take place from hot to cold or cold to hot. That is actually not right to say. Heat transfer is always going to take place from hot to cold only. From cold to hot, heat transfer is not going to take place. Are you getting?
Yes,
even in refrigerator, what happens? We are supplying the refrigerant at a very low temperature. The evaporator temperature is higher as compared to the refrigerant temperature. So some kind of effect we are getting because we are extracting the heat from lower temperature, rejecting it to the high temperature. But heat transfer is not taking place from kind of low to high. Is it clear? And it is not actually right to mention that in the definition of heat transfer. Heat transfer always takes place from high to low only. For a wall, whether you are keeping the insulator, lower insulator inside, outside, or in between, that is not going to affect the heat transfer. Total resistance will remain same. But yes, if you are having a cylinder, some kind of pipe, in that case, it is better. It is good to keep the better insulator inside. Okay, because in that case, if you are keeping the better insulator inside, the total resistance will be much higher as compared to if you are keeping the better insulator outside. Are you getting, Surya?
Yes, sir.
So for the case of pipe, it is fine, right? But for wall, it is not going to change. Whether you are keeping the insulator in between, outside, or maybe inner, inside, in all the cases, total resistance will remain same. Heat transfer will also remain same. Fine, Surya?
Yes, sir.
Steady state, how you can check? You can simply check the variation of temperature with the time. If the temperature is changing with the time, it means the body is not in steady state. Yes. If the temperature of the system is not changing with time, it means it is in steady state. Sorry. And temperature measurement is much more easy and direct as compared to the entropy measurement. Okay. Yes, so you need to define the steady state. So steady state means properties of the system or the control volume are not changing with time. Okay. So there is no accumulation of energy is taking place. Whatever mass is entering, that is equal to the mass leaving, or whatever energy and whatever energy is entering, that is equal to energy leaving. Okay. In case of heat transfer, we can say heat in equal to heat out. Yes, sir. So change in internal energy of the body with time, that will be zero in steady state. Change in internal energy of the body will be zero with time. So when the change in internal energy will be zero, it means what? The temperature of the body is also not going to change with time. Yes, sir. So try to relate the things. What idea we get from the time constant? Less is the time constant of a body, more will be the sensitivity of a thermocouple. Response of the thermocouple will be very much quick. So time constant tells us about the response of a temperature measuring device. So if a time constant is lower, it means response is much faster. If the time constant is higher, it means response will be much slow. Is it fine, Surya?
Yes, sir. Yes, sir. Noting down, sir.
Hmm.
Yes, sir.
Fine. Gray body emissivity are not independent of wavelength. Emissivity is a function of wavelength, even for gray bodies also. Because if you plot some graph between emissive power and lambda, you're going to get some variation. You're not going to get some horizontal line for gray body. So what is constant? Spectral emissivity. Spectral emissivity is independent of wavelength. Is it fine?
Yes, sir.
I think last question you answered correctly. The emissivity and emissive power. So overall, your knowledge is looking fine, Surya. But small mistake you made in some of the questions. Otherwise, your knowledge is fine, Surya. Okay. So keep preparing. Good luck, and anything now if you want to ask, you can ask now.
Okay, sir. Okay.
Okay, Surya. Good luck.
Thank you, sir.